Hi,
Archit,
Daru.
how are you?
Good. Let me try share the slides. So Joe, can you see my slides?
Yeah. Is it possible to do full screen for you?
Let me check how to do this.
This is you're sharing it via PDF on.
Yeah,
Is
it's a
is it
PDF.
Acrobat PDF viewer?
Yeah, probably, but I don't know how.
Usually it
It's
has view button, view full screen, or view present. That option is there.
it's
I
not
can't.
an Acrobat. It's not an Acrobat. It's very close to the Acrobat.
It's okay otherwise. Big enough. I was just saying if it's possible, then it's fine. Otherwise, it's okay.
Yeah, I found.
Sure.
Yeah.
Just try clicking. Yes, perfect. Now it's full screen.
Let me. It works. I
Yes.
scroll the slides. Okay.
Yes, it's working.
Okay. So talking with the Meta, I will share the slides, but I need to make a switch. Maybe will take time. So I download all the slides in a local disk.
Perfect. We have some. You can also merge them. You go to merge PDF and just merge all of them into this thing. That's also is an option if you want to. If you think that switching slides is taking time.
Yeah,
That's a really good suggestion. I wish I thought about doing that.
yeah.
Do you want
Maybe
me
it's
to merge and send
too
it to
late
you?
because first, yeah, you can merge send to me because
Yeah.
for some presenter they want to change the order.
Yeah.
For example,
Oh.
Thomas will have some
Yeah. So
conflict, so Louis will.
Yeah. So let's not do that. It's okay. It's just a matter of few seconds. It's fine. If you are expecting order change, then yeah, it's okay.
Part of my problem yesterday was that I was trying to go full screen every time I was presenting. And but if I had not gone full screen, then I don't think it would have changed what was the first slide that was being presented. But but then you have the tile view down the left-hand side. You don't want to show that in a professional presentation environment. So that's why I was going full screen.
I think here full screen seems to work.
Yeah, it's a full screen. Actually, I cannot see everything. So we don't have a page number for each slide actually.
As chairs, we ask everyone, and sometimes we forget.
Yeah. Let me check some other. Yeah,
other people have. Like I've seen most.
They do have.
Yeah.
Yeah. Right. Yeah, this one also have.
Yeah. Don't worry. So it's Thomas is running late. Is that what you've heard?
Yeah, Thomas will running late, so probably Louis will take his order.
Okay, understood.
But Louis prefer he will run slides by himself
Yeah, that's fine.
because yeah.
You're missing Warren, because usually when Warren is there, there is always chatter.
If I share the slide, I cannot watch the queue, right?
That's right. It is Yeah, Med's joining, so he can watch the queue.
Yeah, I'll be tracking that.
Okay.
Hey guys. Hi there.
It's awfully quiet in here. Have you really not learned the snark bit yet?
We were waiting for you to join.
Ah, fair enough. We're waiting for
I
your
was
time.
wondering whether I should advise Suresh that he should take the lamp out of the frame.
The lamp is up there.
Yes, I
Yeah,
want to do
so
this as well. There we go.
Looks
trying.
like Zeus is throwing thunderbolts at you.
Or it looks like he's got a halo, which is probably more what he was aiming for.
I'm blessed, Karsten.
Yeah, and with this word, I think we can just start. So Shane, please.
Okay. We about start actually. Yeah. So welcome to this IAB workshop on network management. Welcome to our second session. So my name is Matt and I moderated the discussion in this session. So we also have Wes and Daru and online as a workshop chair. So in the previous first session of yesterday, we take you walk through state of art and reflect what lesson we have learned and revisit all the past existing deployment and to explore and what works well, what doesn't work, and why. So in this session, we want to focus on new problem identification, new requirements sketching. And for new problem identification, we really want to focus on to explore new challenge and issue in the present implementation, software development, and deployment. So we also want to explore a little bit about what factor inhibited the network management technology to be widely adopted. And so
Chill.
hopefully we can have
we are seeing only the
interesting
title
debate
slide.
for this. Yeah.
We are only seeing slide 1. Have you changed?
Yes.
Are other people seeing slide change?
Make change. Yeah.
I'm only getting slide 1.
No, I still
Yeah.
in the first slide.
You're still on the first slide. Okay.
Yes, I didn't make a change in the second slide. So in addition for new requirement sketching, actually we these requirements are not coming out of the blue, and they derive from the set of the position paper we present today, and also derive from the survey and the operator reach out summary, and also the open discussion today. And hopefully we can converge on these requirements, identify some missing requirements, and we also want to point out for the position paper, many of these position paper not only touch the past and the future, but also touch the present. So really, we want to encourage the people, for this author of this position paper to don't hesitate to contribute this discussion. To have productive discussion, the session will start with the initial presentation. So please limit your contribution to clarification question for each position paper, since we reserve a big chunk of time at the end for open discussion. And we also, want to mention, for this, we use WebEx for session discussion. So the WebEx chat window will be used to manage the queue. If you have any question, please enter +Q in the WebEx chat window to queue up for your question and comments. And also, this session will be recorded. If you feel not comfortable to be recorded for specific portion of the discussion period, please let us know. And also, we will take a meeting minutes using HashiDoc and use HashiDoc to connect the key takeaway and next step. And in the key takeaway next step, we already populated some of requirements as a reference requirements. Please, let us know what is the missing requirements, whether these requirements meet your needs. And please, get access to these two links, and feel free to contribute and help. And as I clarified earlier, the focus of this session will be the scheduling new requirements for future network management operation. And after decades, medicine has changed, and also how the network can be managed also get changed. Therefore, it's important to, make industry player and operator and protocol developer, all the stakeholders to work together. And so this is the agenda for today's discussion. and so we will, hope you can stick to your time for each presentation, and then please reserve some time for question and answer. So any agenda bash? Seems no. So let's move to the first presentation, Holger, and the topic is obviously 35, and the forgotten words or provision is only a subset of network management. So Holger?
Yeah, thank you.
You want me to share slides?
Yeah, you can share the slides.
Okay.
With just a few slides, it's easier when you are sharing that.
Yeah. Please go ahead.
Okay. I'm not seeing the slides yet, but yeah, I'm Holger from DT, and we, as 4 people, wrote a position paper for that workshop. It's namely me, it's Rüdiger Geib, Martin Honnefer, Nils Wanke. So when we analyzed RFC 3535, I saw that, or let's say I did a quick search on wordings, and if you look for configuration, you see that the word configuration RFC 3535 is all over the place, which led us to netconf-yang, something we saw and discussed yesterday. If you search for other stuff like monitoring, observability, whatever, you find 2, 3 hits. There is a chapter with SNMP. There's not much. From an operator's perspective, yeah, 20 years ago, the requirement was we need improvements on configuration stuff. Yeah, but it's not everything, and this is what we wrote in our position paper. And I want to show that with some examples. And now, just as a little note, the requirements here are, let's say, look like a bit hard, like hard to reach, and that's why I wrote here. We are creating somewhat a vision for the next, not 20 years, but I would say 10 years. So it is a goal we should reach in some years, not next year, not in 2 years, but in the next 10 years, let's say. So next slide, please.
Yeah, can you see the slides change?
Not yet.
It's changed now.
Okay. So just again from us, Yang is great for provisioning. Yes, it is. Really, we are using that in a backbone in our orchestrator. However, it is working flawlessly most of the time, not every time. What we see is, for example, ITF service models are in a good shape. Where we struggle with is the open config part. We wrote here unstable. What do we mean? When we decided to use Yang in our orchestrator for configuration stuff, we looked at the feature richness, for example. We looked at the implemented versions from our vendors. We looked at the version that is most current in the repo, and we saw there's a lag. We estimated about 1 year that an open config model was behind the network vendor model, the vendor model from the devices. And if you need a new feature, you can't wait for a standardized model or a multi-vendor model, because you want it now, and that's why we decided to use vendor Yang models. And unstable also, we have an orchestrator that is very strict on Yang validation, and we see very often little issues. There is a leaf that is not present in the router, but should be, because it is in the Yang model and such stuff. So that's why we decided to leave out standardized models, and ITF would maybe hit the same issue. Slides are gone, just for notice. So I can continue. The next line would be mapping between services and device model is currently time consuming. That's one of the hardest things that we had at the beginning. We have service models for various services with really different purposes, and you need to map all those Yang leaves from your service to the devices, and you have a multi-vendor environment. So this really it took I would say 50% of the time. The other 50% were really testing, but it took us really a lot of time. And slides are still not back. Maybe should I share?
Yeah, if you have the slides ready, please go ahead and share.
Yes, just ready is not.
I can bring them up. I got them.
Okay, thank you, Kent. So slide 2, please.
Yes, I'm trying to go to slide 2. Oh, okay.
I remember from.
Yeah. Okay, I have to do the. Okay, hold on. Let me go full screen, and then I should.
Just scrolling by head.
Okay, I'm gonna have to scroll. Okay, go ahead. The slide 2.
Yeah, thank you. So and what was the main advantage of using Yang during the last 4 years? Nearly 5 now that we really use Yang in production on the backbone side. We have 2 vendors. We had 13 software version upgrades over all our platforms, and it required only 3 changes in our vendor packages. The packages from the orchestrator that talk directly to the device models. 3 changes were necessary to adapt during all those 13 upgrades, which is rather great. It really reduced our efforts. We could invest testing time for the services and so. And we still have some CLI devices. I can't give numbers for that because they are so old. We do nearly no change on that. So that's why we just have them for inventory reasons. But yeah, I think this is great. 3 changes in 13 software upgrades for 2 vendors. That's really impressive and made our life a lot easier. Next slide, please. But when we are using our workflows in the orchestrator, the configuration part is really the part that is not that takes least of the time, least of the testing and whatever. Here's an example. I have counted for 2 of our services. One is simple link provisioning. When you go from like an empty config on the device to a complete ready in routing connection, we do 4 config merges, but at the same time we are using 11 validation requests for that. We're splitting the config merges up for various reasons. For process reasons, for example, we have something like frozen zones where we are not allowed to change something to be on the safe side. And that's why we said let's split it up so we can at least do a little bit of work during a frozen zone with stuff that is not dangerous for or affecting us if it goes wrong. And so we have 4 merges, but as said, we have 11 validation requests, for example. And the next one is the software upgrade. We have 5 config merges there, and you see we do a lot more validation on that. Like what is the status before the upgrade, what's the status after the upgrade, and so on. And here we even have the issue that we have to use CLI for that, for config as well as for getOpera. This is, I mean, it's not much, but it still is. We are in 2024. We saw the timeline yesterday of Yang and so on. So yeah, we still have to use it. And the last slide. So yeah, requirements. What should I say? I don't know how it is for other operators, but NDT, if you are talking about monitoring, observability, a lot of people think that costs money and brings us nothing. Or you need it once a year when you have a bigger outage, then it's good. But yeah, that's somehow, let's say, opinion for some managers here. We can prove that this is wrong, of course, but you have to enable, or you have to start changing their minds somehow. And I think currently the time we are in is the best time for doing that and achieving that with all the requirements we have with big data, with AI. It was never easier to tell something we need good and much more data to create the use case that you want. So what requirements do we have? We have managers, NDT, that are already talking about autonomous networking. We are on the way, whatever. I mean, we're on the way since 25 years, but we're still not there. I think together we have some requirements for the data, for the operational data to get out of the boxes. That's why we said real time, 1 second. I know that is ambitious, really, yeah, but let's say that's the vision that we have. Real time. So the next requirements. I know we don't need every single leave in real time. There's for example inventory data that you don't need every second. You need it when something changes. That's why we're going for unchanged here, for example. And we know this is not implemented everywhere in the industry, but it should be. That's a requirement. The next point is somehow really interesting for me. I mean, IETF is not really in a position to influence that. I mean, every vendor has its internal structures for the hardware, for the operating system. But as an example, we collect data for traffic engineering. We collect 3 terabytes of data for traffic engineering every day. And we're doing this only every 15 minutes because we have routers that take 11 minutes to stream out all the data with GNMI. And the traffic engineering guys asked me, can we do this in 5 minutes? And I said, let's have a look. Most of the routers are faster than 5 minutes, but we have 50, 60 big boxes that really need more than 10 minutes to send the data. And this is something we need to work on. And as I said, I know that won't be easy. I don't know if we can really do something on the IETF level there, but at least we can talk about that. What are the requirements from the operator side? How can you optimize that internally, for example? The last thing here, what we talked, scalable 100% standard device model coverage. This is in regards to the point that we have still to use CLI for some few things. And the last point is something, if you look at interface counters, for example, if you count on layer 2, there's a VLAN tag. We have vendors that are not counting the VLAN tag. We have vendors that are counting the VLAN tag. So our requirement will be specify that in a way that every vendor is counting in the same what do I want to say? Yeah, it's counting the same. So because if you have a multi-vendor network, you have to do adaptation on the IT side, and this is always costly, slow. So that's why I think there we can improve a bit.
Yeah. So Olga, if you can just wrap up as we're running out of time.
This was the last point. So I think we have everything here.
Yeah, so thank you, Olga, and apologies again for the inconvenience for the showing the slides. Any clarification question for Olga before we move to Jaime? Jaime, in the meantime, you can prepare your slides, please.
I thought you would be sharing them.
Yeah, please share them. That will be more convenient. Yeah.
So I share. All right.
Yeah.
Just a second. All right. Do you see anything?
Not yet.
Not yet.
Something seems to be loading. Otherwise, if you can share, that would be great as well.
Maybe
You are allowed
I
to
can
talk
share
without
again.
us seeing the slides.
Yeah, I can also talk. Sorry for wasting your time. So basically, the presentation is an effort done by R&D. So basically, it's me, Scott Mansfield, Raquel, Miko, Besa, and Yane, and we will split the presentation between the three of us. So let's start with Raquel right away. Yeah, go ahead, Raquel.
If that shows now. So do we see the slides now? I think I
Yeah,
see.
I'm sharing slides. Can you see that now?
I
don't see them yet.
Screenshot for the screen.
I see somebody's WebEx client window.
Maybe I try to share myself, if that is okay.
Yeah, sure. Yeah, sure.
No.
Oh, now
Let me
we
stop
see.
sharing.
Okay, very good.
Now we see the slides.
Yes.
Not anymore.
Now we don't see the
It's
slides.
stopped. Shouldn't do it again.
Okay.
Okay.
I
Do one
share
person at a
from
time.
my side.
I sharing actually. Let me do again.
Yay!
Yeah.
Nobody touch it.
Yes. I think you should be able to see them now.
Yeah. Now not anymore. Somebody took over.
Please, only one person share
I
it.
think somebody's taking over the presentation, and let's just go ahead and present whoever it is.
Okay, very good. So yes, so thank you, Jaime. So yes, we are here. We are here presenting our vision of what we think that the transport automation platform should have to be able to manage networks from today and the networks of the future. So there is this kind of two big pillars around network management. And of course, we've been talking a lot about the provisioning and configuration, and this is key. This is something that you have to do in your network. But once you have provisioned, you have to be able to, since the networks are dynamically changing, you need to have very good observability and analytics. So that's a very important pillar in network management, especially when you are aiming at finding patterns from your network behavior or PM data telling you that hey, you have some instability in the network, in your BGP table, in your routing tables, or in your microwave links. So observability with high granularity is key on that, and that observability helps you to then automate closed loop towards the network. So having that is important. And of course, not all the networks are of the same size. So as a vendor, we are making this kind of working in platforms that would work for smaller customers, smaller vendors, smaller operators, and operators, tier one operators that have really huge network base. So having a scalable architecture is key. So we are really leveraging microservice-based architecture so that we can scale southbound adapters towards the nodes and also towards the OSSs, the northbounds. Transport networks are by nature very heterogeneous. So if I compare it to RAN networks, and you look at one operator, transport networks usually in one single operator instance are so that you have multi-vendor landscape. In RAN, usually you have 1-2 vendors. So really to be able to manage microwave, IP, and optical domains of the customers, of the operator, in a multi-vendor environment, I mean, this is why we are here. You need to endorse and really be open to have a standardization. So challenges, if you move to the next slide, please. Challenges are on the next slides. Could you please move to the next slide?
Yes.
Yeah, the challenges that we have seen when working in legacy and multi-vendor networks with many operators are like these few big areas. These are the things that we think that should be kind of improved in the long term. Data streaming, because as it has been also mentioned by other people here in this workshop, legacy systems are really like relying on periodic update. We need to have access to what is happening to the network in a more granular way. So streaming is key because it's the tool to understand what is happening in the network if you need to trigger closed loop automations back to the network. For example, figuring out that, hey, you have to optimize a path for a IP tunnel. So if you see congestion, you route it through other part of your network. This kind of information is key to have it really with high granularity. Data schemas, we see that, hey, there is all kinds of job models up there, defined in IETF, in OpenConfig, defined even, we see job models definitions for example, synchronization, PTP protocol in the routers, okay, in ORAN. So there is all kinds of job models, and sometimes they are not very cohesively working together because you need to treat the network as a system. So these job models should be built in such a manner so that you can relate services with the ports in the node, with the hardware units in the node. And of course, there is always vendor implementation deviations. Security, I think, is the forgotten child always, in a way, because the fact is that there is a lot of legacy in the customer networks, and security will be, it's complex to manage when different nodes have different security protocols. The operators struggle with that. So I think we should aim at looking at unifying how we manage security in the networks, in the transport networks, giving guidelines. And of course, data scalability, and we have touched about this a lot. And I think we could move to the next slide, and my colleague Scott will continue in the data scalability topics.
Yes, I hope you can hear me all right. Can you hear me? It says I'm broadcasting.
Yes.
Thank you. So I have a couple slides here that try to drive home the points that we've been seeing, and looking at the other presentations that have been collected for this workshop and looking at the list of Yang Next. I don't think anything on this slide really will surprise people that are in the know in this particular area. What I use this slide for is to explain to people what Yang is, why it's complex, where there are some things that could be improved. And so the examples that I'm providing are just showing that, well, what would happen if you have a device that has 100,000 interfaces, right? How do you deal with that sort of thing? So scalability is very important. Understanding that management networks use bandwidth too. So the amount of time it takes to transfer management data from one place to another, or the amount of data that you use when you're doing telemetry or streaming, is very important. Something that Yang doesn't have a lot of is ways of doing queries. And so having querying, there's indexing, but it's a flat file data structure, right? So there are some complexities in navigating a flat file data structure when you want to treat it as a set of objects, for instance. So there's plenty of opportunities for things that could be modified and expanded here, and a lot of these are already covered in the Yang Next database. So if you go to the next slide, The next slide is evolving toward the future, and what it talks about is the fact that there is, for data and security, we list a few things that these are the areas that we feel that Yang or something like Yang will have to evolve in order to reach a future where we have autonomous and automatic configuration of things, intent-based networking, and all of the buzzwords that people like to talk about. But down at the IETF and the bottom-up level, we do need to expect that there's going to be telemetry in every node. We need to be able to select the granularity. We have Yang push, but then you need to have the equipment that can actually support doing it at the levels that you want. There's the over-the-line transmission efficiency. We have a lot of examples in automotive and in aircraft, aerospace applications where they have low low capability systems that they want to hook into this environment. So they need to be very tight in how they communicate, and then they want to then take it back to a netconf proxy or some such type of idea like that. And then data schemas and definitions, and having metadata about the data so that you can do translations between models. That's also very important. And we talked about security, just unified security approach, and you need the security for the underlying transmission of what Yang is sending, and then of course the security over the top. So I'll leave it there and turn it over to Yame.
Yeah.
Thanks.
Yes, so let's go next slide. Actually, let's, for the sake of time, because I guess we are a bit behind, let's jump one more, please. Hello? Okay, fine.
Yeah.
I will talk about the slide one more, about the slide, the next slide on AI agents. So in the IETF and elsewhere, there is a lot of work on agentic patterns. So what is an AI agent? Is a system that is LLM based that can decompose, it's in the next slide, by the way, can decompose a high level intent into smaller actionable items. Quinn, please, could you pass to the next slide? Could you be so kind?
Yeah, next.
Thank you. Yes, so it can decompose a high level intent into smaller actionable items that can be interact with existing tooling. So for example, APIs. And it allows basically to, for a network administrator, for example, to provide this high-level intent, like lower the QoS of that endpoint. And the agent should be capable of, with very little a priori knowledge, but with the YAML of the APIs or with the schema files or with the information models of the entities that it is interacting with, to be able to send those commands successfully, retrieve the responses, parse them, and understand them, and be able to do the high-level intent that the user has set. So this is quite interesting because from the point of view of the industry, also you see a move to network APIs. Everything is being API-fied. Everything that has not already been API-fied is being API-fied in a way. For everything else, you also have other interfaces. And in the IETF, there is a lot of interest. There has been many side meetings since Brisbane until the last IETF, but nothing specific can be standardized right now. So there is no specific interfaces that the industry could standardize right away, but it's not unlikely that some will come. Maybe something about enhancing the descriptions that are there, maybe something to facilitate the agents to interact with systems, maybe something on authentication, authorization. There could be something there. So this is not a specific RFQ or a specific requirement, but it's something that may be coming soon. And then the next one, the last one, or can you pass to the next slide, please? Is about retrofitting IoT-oriented protocols. So those of you who were here yesterday, you saw the presentation from Karsten. I'm kind of reiterating a similar story here. In the core working group, we had years of work around IoT protocols that are for devices that are very constrained in memory, in computation, in battery, and that are not also intermittently connected. So we have built a protocol called CoAP that goes over UDP initially, although now works also over TCP and other transports. And that is very small, is very oriented, initially was very oriented to telemetry, but not only, is REST-based. So if you are familiar with HTTP, it's more or less the same pattern, similar methods, but with additions. So you have other methods, for instance, patch, fetch, that allow you to partially manipulate resources. And I have heard yesterday and today, and with my colleagues, we have been talking, there's a lot of apparent telemetry issues, like a relatively large payloads that could benefit from this set of protocols. Somebody mentioned yesterday data at the storage level. So for instance, instead of storing large amounts of data, you could compress it with CBOR. There's a binary compression there. Similarly, there is other tooling that could be used that we have done also in core that could be useful for this type of setting. So UDP multicast is something that COA works really well on. And yeah, and the last item, sorry, basically security. We always talk about TLS. Yeah, we always talk about TLS and DTLS. There is also other forms of security like cross-core, application layer security. So if you're interested in end-to-end security, maybe something to look at as well. That's it. Sorry for the speed. There's the last slide. If you want to, I can do the wrap up, or I can do the wrap up. Yeah, it's a summary basically of what we have just said. But if you could be so kind to pass to the last slide. Okay, well, thank you.
So
thank you all.
So maybe we move to the next presentation is from Luis. I will stop sharing. So Luis, Liz can take over.
Yes, I will take over. Just 1 second, please. I will share my screen. Hopefully
This is Liz. I can also do it. Luis, would you prefer to share? I can do it if you like, or if you'd rather share your own, you can.
I'm sharing now. Can you see my screen? Maybe not yet.
Not yet.
Give me just 1 second. Oh, sorry, I forgot to to activate the sharing. So maybe now you can see, right?
It's
yes.
Coming.
Yes. Okay. Thank you. So so let's go for that. So I will present this slide that basically summarizes one of the drafts that we are submitting to MOP, which is basically about an update on operator requirements on network management and protocols and modeling. So I will do on behalf of my co-authors. You can see there, Matt, Oscar, Thomas, Reshad, and Lionel. So, okay. 1 second. Okay, the motivation is clear. It's the same motivation as the workshop, these 3 days. So I will not spend too much time here, just only to comment that the idea of this document is basically to capture near to go through to make a kind of assessment of where we are and basically identifying blocking points. So no more than that. So entering now into the details, so I will go through the different requirements that we have been collecting so far, making a reference to the section where you can find the requirements. Just to mention that whatever we are seeing, we saw yesterday, we are seeing today, and probably we will see tomorrow. Some of the topics are already identified so far, so probably it's a bit redundant in that sense. But okay, somehow you with this, you will see how the different fronts that we are trying to address. So yeah, where we are, let's say, putting the different requirements in the context of the different topics. You can see here a number of gray requirements. This is because Thomas will cover later on in his presentation these particular requirements. So I will concentrate on those that are in black color. So starting from the initial point, the importance of the data model, this is a generic requirement. So essentially here, the point is to insist on the necessity of going into the standardization of data models, complemented by the open source projects. All of this was commented so far. Here, the purpose would be to enable an easy mapping between the information that we can collect in the layers, between the equipments, the different implementations, and so that we can also feed the control loops, the intelligence capabilities, and so with, let's say, a common substrate of information. Moving forward, in the section about fragmented ecosystem, we are highlighting here the need of rationalizing the data models space. So there are different efforts across the industry, also in different, some other different standardization bodies. And the idea basically here is to highlight the point or remark the point of avoiding redundant efforts. So we need to reuse whatever is available out there that could be valid for the purpose of for a given purpose, and trying to avoid reinventing the wheel once, I mean, every time, right? Moving forward, The following section is about the network becoming consumable. This was also commented a bit by Jaime before. So we are entering in this space of the API. So here, well, let me say that there is a missing requirement here. Apologies for that. In the document is included, but I didn't include here in the table, which is the possibility of having an AC exposure of capabilities of the network. So the services and the capabilities to be exposed through APIs, but also we remark here the need of having a means of discovering the available APIs, so that somehow the network can be consumed in an easy way, in an automated way as well. Then moving forward, for the lack of profiling, here basically the requirement that we are highlighting is the need of having a set of recommendations that could identify core features or key features that would be of general applicability. So somehow having a guidance of how to use, how to consume the different models in kind of best common practices, so that somehow whatever operator enter into the space has a kind of reference on how to use the available models out there. I will move now to the next slide. So we cover also the need of the manipulation of the YAML formatted data. Also, this was also commented to some extent by Scott before. So the need of finding ways of scaling better the YAML models. By now, the YAML models has this flat tree hierarchy. So in some cases can represent some performance issues, let's say, at the time of processing the data from the YAML models themselves. And also, the idea here, we added a new requirement about the need of looking ways of translating the YAML-based data into the knowledge graph, so that we can go higher in the abstraction and also correlate with information that could come from other domains, for instance. So next point is about the translation and mapping between service and network models, and then the device models. So well, we have this hierarchy in ITF, or the service, the network, the device models. So in such a kind of hierarchy, we need to ensure that the mappings are lossless, that we don't lose information, even though it could be also the case that probably we don't need an exact one-to-one mapping of everything. So probably could be the case that for some attributes, we can have not a direct mapping, because for whatever reason internal to the operator, maybe we can go through other sources of information. But at least in the process of from the service up to the device, ensure that there is a complete mapping, let's say, that a valid mapping of parameters, so that we can ensure that all the chain of translation is valid at the end. Then moving forward, for the next point will be about the consistency or inconsistency of data structures at the time of exporting data. This refers more to the telemetry data. So the idea here would be to have common data structures in network telemetry protocols that at the time of exporting the information could provide a complete view, let's say, of the different network segments. So trying to look for that consistency on the data structure and the information that we expose or we export for operational purposes. Next is about the point of now we are also observing distinct networks with distinct management requirements, different management requirements. There are specific network management requirements for networks like delay tolerant networks, deterministic networks, or deterministic networking solutions, and so on and so far. So somehow in the multi-service networks of operators, we are also trying to address services that were not present in the past and with the specific needs. So we need here to identify how to be able of managing, to what extent can be possible to manage all these different specific needs, with following the similar approaches. Next is about the implications of external dependencies. Here, the point is to being able to manage problems of heterogeneity and data reconciliation between different different, let's say, network environments. Here, for instance, I'm referring to integration of IP and optical, or the front haul, or information that could come from data centers and whatever. So we will have, let's say, the need of working with data coming from different layers, even, or different technologies. So work on this possibility of managing this heterogeneity in a in a handly way. I will pass to the next slide. So regarding the next section, the next requirements that we address is the time that is taken between the publication of a new networking functionality and the availability of the associated jam model. Probably here the requirement that we are raising here is to accompany the specification with some also definition of the jam model, or even that the jam model can progress in parallel to the feature that is being proposed, and so that somehow we could shorten up the time between the availability of the model versus the functionality that is being defined. Next is in some cases, the lack of implementation of proposed solutions. So in this case, for instance, in new solutions that could come in different working groups like NetMod or NetConf, and so sometimes the implementation is not accompanying the solution, or is it partially accompanying the solution. So having let's say the more complete implementations that we could have, the better for adopting sooner the different solutions. Basically, this is the point. Next aspect is about the integration of native IT tooling. Here, well, it's self-defined. So in the IT space, there are a number of tools that are very valid tools. So here the point would be to find a way of integrating those tools also in the machinery of tools for network management, so that we can leverage on them and accompany the overall network management capabilities and functionalities with these other available tools. Next point is about, or basically the two next is also talking about tools essentially. So the point that the IETF should support better YANG integration and also the availability of open source tools. At the end, these two requirements goes in the same direction. So having availability of new tools for speeding up the adoption, the experimentation, and the refinement of the models. The penultimate requirement here is about the skills. The point is that the IETF is probably not a data-oriented community, or at least until now. So basically here the point is to find an ecosystem that could help us to find a space of collaboration with data engineers. So essentially, now that we enter in all this AI, that, as commented by Jaime, the control loops, this kind of thing. So acquiring the capabilities as well of processing and managing all this data that will be generated from the network. And finally, in this slide, also to remark the fact that there are new services approaches. So, for instance, all these, I think also was commented yesterday. I think we commented as well, all the Kubernetes, all this stuff. So there is a more and more integration between compute or cloud native services, making use of the network. So typically they are using this overlay solution. So the idea here is to work on having an efficient interplay between these new modality of services that are more leveraging on cloud capabilities. So this is the last slide, quickly through two remaining requirements. One is about the lack of guidance or clear applicability of the documents. Here, essentially, the point is basically that, to have clear ways of applying existing solutions. There are, in some cases, different ways of reaching the same solution. So having a clear guidance, what solution to use for whatever purpose and so. And the very final case, and apologies because it's not in order, is the appification topic that we commented also before. So the idea of linking the specification of APIs with the YAM specification, so somehow helping on this translation and linking both sides of the same automation story. So these are the requirements that are documented so far as a summary, and now concluding. So our idea is to collect these new requirements, to document them. The idea is so far to work on prioritizing those requirements from the operators, but for the community in general, so that we can focus on those that could be more impactful in short term, leaving the rest for further iterations. And we are pretty sure that all the discussions here in the workshop will help to do so. So yeah, thanks so much for all the discussions, and yeah, let's keep working on this. And that's all from my side.
Thanks, Luis. So, any questions? So maybe we don't have time to take question. Maybe move to the next one. Is online?
Yes, I. Do you share the
Okay.
slide screen or should?
Lisa, please.
Okay.
Yeah, Lisa. Yeah, we'll do.
Martin,
Okay.
can you mute? I think we are getting disturbance from you. Thank you.
Good, then I get started. Thanks a lot on behalf of the authors, Holger, Dan, Paolo, Benoit, Rob, Alex, and Pierre. So before getting started directly into slide deck, let's reflect a little bit on network telemetry. We have various protocols how we can collect metrics from the network, for instance, IPFix. And if we look at the history of IPFix, we know that it started as a product by a vendor. And then over several iterations, it arrived at ITF. And today, it's a great success. I think there is almost any vendor, any implementation is supporting IPFix. It's very much interoperable. If you look on the other hand, like on BGP monitoring protocol, we have a very simplistic protocol, which is basically just building on top of BGP, adding some additional metadata, and then basically mirror the BGP information from the network and add some additional counter statistics on the protocol. So it was very easy and straightforward to implement, and also with the same results that today many of the major vendors are supporting that protocol, and within the ITF, it's being now developed in a very iterative approach. But I like to start here more on the third protocol, which is Yang Push, which I believe is a bit like the troubled child from network telemetry. And I would like to start with some history and current challenges, and at the end, how agile increment-driven development could resolve some of the problems we have there. Could you please go to the next slide? And in the first day, we heard our last ITF IAB workshop in network management. It was in 2002. And to paraphrase, to simplify it, the requirements we set there was to lifecycle CLI and SNMP. And out of this, Yang NetConf and RESTConf development has started. And in 2010, basically Yang was specified with version 1.0, and 5 years later, the development of ITF Yang Push has started. While still the development was ongoing, the industry could not wait, and parallel, and we heard it yesterday from Rob Shakir, that the GNMI development has started, and in 2017 it was presented to the ITF, and there with the comment that basically ITF is not quick enough to develop, so therefore this group chosen to do the implementation, the specification outside of the ITF. Then in 2019, the development, the specification finished with ITF Yang Push, and I'm here noting that on the positive side, because the transport protocols for configured subscriptions are still under development on the ITF side. We are looking very forward to having the HTTPS and UDP native soon being RFC, so that also configured subscription, we have RFC numbers for it. But in 2019, there was still no major vendor who started actually working on a Yang Push implementations. And then when we started at 2022, with the pain on the network operator side that we have now many vendor-specific implementations on subscribing to Yang information in various operating systems. And to maintain these data processing chains is quite a challenge for an operator, especially in an interoperable fashion. We were looking into ITF Yang push and existing vendor-specific implementation, and we looked, do we have a full coverage from a feature set point of view? What are the things which are currently missing in ITF Yang push? What has been implemented on the vendor-specific side? And also, since it's not only the network, it's also where to integrate to. So basically the data mesh side, we brought all these minor enhancements into the ITF in various documents so that an implementation on the vendor side and also an integration into data mesh can happen easily. What happened then is in 2024, when more and more vendors started doing implementations in ITF Yang push, we got many questions. Questions on whatever, like, do we really need to implement that feature? Why was the feature specified that way? And since we got from various angles those questions, we started channelizing that information and we started organizing private side meetings. Next slide, please. So in order to, let's say, the state of the union here is basically today, when I ask a network operator, how long does it take to onboard new Yang information from the network, and finally a network engineer is able to query? Is it minutes, hours, days, or weeks? None of them answer minutes, maybe 1 or 2 hours, very seldomly. Mostly it's days or weeks, or in other words, basically today, in order to onboard new Yang data, manual work is needed. So it's not that easy and straightforward for an operator today to handle operational Yang data. Next slide, please. So when we started in context of the data mesh integration and reviewing RFC 8639 and 8641 and having those feedback from the vendors on questions on implementation, we did some key questions to start understand. So what's the state of the union here? What are the things currently going on in the implementation side? And on the right bottom side, these are the questions where we were asking. And next slide, please. And in these side meetings, I think it started around July this year and then ended in October. We were approximately 34 people, and we wanted that basically the outcome of those meetings are made available to NEMOPS working group, but also to NEMOPS. And at the bottom, there are a few things like where the participants say they like about ITF Yang push. But there were also some comments about never going to implement that. That's not really bringing us additional added value in here. Next slide, please. Now, there were also some things where the feedback was, well, we want to have it implemented differently. It's not the way how it could be implemented easily on the network vendor side. And we were starting to take these things up, and in some of the documents which we presented very recently, we started addressing these things. However, there is one point where we cannot address in a document, and here we need a change in the ITF process itself. And this is why I'm here at NEMOPS to start discussing on agile incremental driven development. Next slide, please. So what becomes clear if we make a summary on what I just have explained before, that ITF developed Yang push not according to network operators' needs, nor network vendors' constraints, nor considered where it should be integrated to. And most importantly, it lacks agile increment-driven development process. Next slide, please. So what we are proposing to IETF as requirements are the following. User first, no requirements without use cases. We have a purpose why we are building these protocols, and this purpose needs to be fulfilled. We IETF need to be dependable and predictable. We need to deliver scoped items in time with proven implementations. It's not only about writing a specification, we need to make sure it can be implemented in many different vendor implementations, and it is interoperable. Once implemented, we need to assess the outcome of that so-called minimal viable product. And before we are moving to the next, we need to do this assessment, maybe take some points and address it then in the next release. We need a 12-month release cycle, not a 5-year release cycle, where we need to strike the right balance between stability of IETF specifications and the solution. So we need to be agile. So from the requirements that Luis was just presenting before, basically what I've been describing before, that the operators and the implementers came together and starting writing requirements and also guidance and profiling. These things these are the things which I'm describing above. The part with ops requirement reassessment and integration requirements, these are the things at IETF we did already before, but not within the IETF. We did that outside of the IETF and presented then the results to the IETF, to the community, and from there on, we are starting to do the refinement process. Regrettably, these things should have happened at the very beginning of the development process of IETF Yang Push, and that was back in 2015. Next slide. So these are the documents I was talking previously. Some of them are related to the transport gaps, so that subscribed to the configured subscription part. Some of them are specification gaps on Yang Push. Some of them are targeting the integration part, so that the automated data processing pipeline can become reality. Some of the things are about simplifying Yang Push. There are things which should be implemented differently, could be implemented more easily on the network node side, and also other things are not really needed. And then last but not least, the architecture document for the message broker integration. Next slide, please. So we are concerned that what happened in 2017 when basically for the industry that IETF is not progressing fast enough is going to happen again in 2025. So we have currently network vendors doing implementations and also operators who require these implementations, and they're all on a timeline. And we are slowly facing the problem that we are not meeting that timeline anymore. And if that happens, I worry that basically the specification and implementation part is happening outside of the IETF process because we are moving too slow. And we are here to change that. And this is our proposal how we can address that. Thank you.
Thanks, Thomas. So we have 1 minute for question clarification. And Joe, do you want to ask a question? Okay, that's yeah. Thanks, Thomas. Yeah, let's move to the next.
We have to list.
That's a question. Yeah.
Oh, Tolis.
Yeah, so
Right.
thanks. You were mentioning a couple of really strict execution requirements. What's your enforcement strategy? Fire the AD, fire the working group, don't pay the IETF participants, or they are not getting paid. So how do you want to make this happen?
I think ITF already has good mechanics for some of the things. So, for instance, you look at the charter of BFD working group. We have clear milestones, and for each milestones we have documents. I think that's a good example to set priorities, what the working group should be focused on, and also have clear timelines when to go on. Or in general, like in the routing area as an example, we have requirements that we need at least 2 implementations for a document. We do not have that in the network management area. So I think there are already plenty of mechanics on the ITF side, but we need to apply it in here. While on the other side, I think there might be some small changes in the process needed.
Actually, I disagree with you on that one, because it's not up to the ITF, it's up to the vendors. So if the vendors are not, if people are coming with a proposal without an implementation, then that is the problem. The difference is that in the routing area, people come with the proposal once they do the initial implementation. This is what the GNMI, they had the implementation first, then they came to the ITF.
Yeah, please, Dean, if you can just stop this discussion right now and continue with the next one. And just for the convenience for everyone, please, if you want to speak, just write +Q in the chat, so that will be respectful for everyone. Thank you.
Okay, maybe next, actually, can you see the slide to be shared?
Yeah, please.
Okay, great. So next, actually, Ken and I will introduce this insight from operator survey and outreach. I will introduce the operator survey first. And so this, for IAB program committee actually conduct this operator survey and really want to better understand the current network management practice, challenge, and future needs. And also thanks, Jay to help to create this survey. And we also want to make a definite conclusion about, this, for this survey results, doesn't we make any, draw any definite conclusion. And for background, actually, we conduct this survey, receive 79 people to give the feedback, and most of the network operator. And we actually investigate the organization size and also network scale. And for organization size, you can see the left, actually, we have certain people to manage the operation team with more than 101 network engineer. And for in the right side, we can see your network scale. Actually, we have certain people who manage the network scale with more than 1,001 network node. And for network type, operated by this network operator, you can see top 3 network type include WAN network, data center network, and a campus network. And for primary role to take, when this operator manages the network, top 3 primary role to take, include the architect and engineer and developer. And regarding the participation level into the IETF and other SDO, surprisingly, we see more than half of attendee, don't participate in the IETF activity. And but for the people who participate in IETF activities, they also follow some other SDO like 3GPP, HRB, BBF, and also many operator community meeting like Nanlog, RIPE. And regarding the network configuration tool statics and protocol API associated with this tool, as per the survey, most popular configuration tool are Ansible and CLI. And the most popular protocol and API is Netconf. Surprisingly, some consider SMP as a configuration API. For monitoring tool statics and API associated with these tools, as per survey, and the most popular monitoring tool is Prometheus, and most popular protocol and API is still the SMP. And for other tools that manages the networker, actually, Netbox is on the top. Actually, this is not used for the configuration management and monitoring. Instead, they use for IP address management, security management, and power management. And for the people feel the network automation level, and we actually receive and 48 feedback and 32 people, and think network automation is highly important for their organization. And regarding to what extent for this network automated, we receive 49 feedback, and 13 people, they are not a network has already highly automated. And for streaming telemetry, actually, we don't make distinction between different type of streaming telemetry technology like gRPC, young push, and we receive 51 feedback, and 26 people still, has already adopted streaming telemetry. So summarize the issue and the challenge with the network management tools and protocols. We can break it down into 4 categories, and vendor issue, young model issue, and the configuration management protocol issue, monitoring protocol issue. And one of the big issue that are common to management protocol and monitoring protocol is SMP, and SMP is too slow, and due to the scalability issue and hardware limitation and performance bottleneck. And also both netcom, rescom, and telemetry lack good documentation, especially for telemetry, and they also need to deal with unstructured data that be defined in a syslogger. So this part is also poorly documented. And the second big issue more related to young data model, and we need to support the mapping. For example, we have service model, network model, and device model. Mapping from service model to vendor specific young is complex and time consuming. And some operator complain about this, to make a customer facing model consistent with the resource facing model to easy mapper is very challenging. The third big issue is more related to the tooling, and especially for the telemetry. For telemetry, we lack a good support to integrate with open source tools. And for young data model language, we library and software tooling. And some operator complain about the vendor are not willing to open platform to integrate open source tools. And also vendor has some specific limitation. It's make API protocol is hard to use. And then the another issue impressed me a lot is about the data processing. And currently we may have some open source to integrate the data connection with the data processing, but we lack commercial test version. We lack commercial cynical support for data tuning and monitoring. And summarize the requirements for network management. And this also can be broken down into 3 categories: young model requirements, protocol requirements, tools vendor support requirements. And these requirements mixed with lower level requirements and higher level strategic requirements. For protocol, these can break down into configuration management and network monitoring. And configuration management top 3 requirements include legacy client with SMP, SSH support. In this way, we can manage a legacy environment, and we need to support non-SSH, for example, netcom over quick. We also need to support flexible encoding involve JSON toward involve from the XML towards JSON and the binary encoding. And for network monitoring, top 3 requirements include lightweight young push, service level monitoring, and binary encoding. The second requirements relate to the young data model. For example, we need to standardize the device young model, standardize the service model, and standardize the model mapping. And the third requirements actually more related to the tuning and collaboration and coordination. For example, we need to better align with the developer community, DevOps, and we need to have magic tool to integrate all the feature. And we need to have financial support for this tool development. And especially for service delivery process, usually they build as a silo. There's a lot of duplicate management process. Therefore, it's important to develop tools to simplify, unify the process. Also, we need to support better network observability, and so we can have tools to expose this network status like BGP peering and traffic route. And another important requirement is go beyond the network monitoring. We need to support better network, better data management. For example, automate data connection, process chain, enable easy data consumption and correlation for data processing. And also we need to build a closed loop to support operation assurance. And another requirements is about container image support for tests such as CI/CD pipeline. This more lower level requirements, but really remind us for some operator they also need to manage virtualized infrastructure and cloud environment. They also need to the better tool. So next,
yeah, Shane, please, if
I
you
want to pass to the
yeah,
Ken.
yeah, please.
Ken.
Okay, next slide, please. Okay, so this is the second half of the presentation. Sorry, can you go back to the title slide? This is the second half of the presentation with regards to the outreach that the IAB program committee did. Sorry, can you now go to the next slide, please? I think there's a lag between here and there we go, perfect. So a number of the members of the program committee traveled to various network operator conferences. Benoit went to LACNIC 42. Myself, Chin, and Warren went to NANOG 92. Benoit also went to RIPE 89, and Mahesh went to AutoCon 2. And with each of these conferences, I mean, there was a presentation that just basically mentioned the survey that was going, and also, of course, the workshop and inviting people to join the workshop. But also there were breakout sessions and opportunities for people to come and discuss verbally what it was that they wanted to. And we do plan to continue to reach out the outreach efforts even after this. Next slide, please. So we collected the responses that we received from the various operators from these, and we broke them up into two categories. There's only two slides. First is our general insights, and the next slide is going to be specific on data models. And each slide is about 7 bullet points or points. So we'll just take them one by one. And these are very raw responses, okay, so, and directly from operators. First, we have in-network deployments. Operations are typically at the bottom of the ladder. It is the most squeezed for time and resources. Network engineers are not typically seasoned developers. Development of needed in-house tools often takes years to develop. There's a need for tools that are easy to use and just work. 2, vast majority of smaller operators use CLI and open source to manage their networks. 3, there's debate fatigue. The protocol model debate is a recurring conversation that's been going on for years. It's not going away, and they're tired of it. They want us to solve it. 4, it was suggested that other domains such as Kubernetes and automation are years ahead of the current network engineering stack. 5, support for multiple friendly, stable, and feature-rich libraries for programming languages is needed. Many DevOps routines use shell scripts. Others use high-level programming languages. In any case, on the client side, and which is, from the operator's perspective, they're the clients. On the client side, multiple programming languages are used. 6, screen scraping is both necessary and evil. This most often occurs when interacting with devices only has CLI or serial interface. 7, it was noted that there could be an outreach to academia to establish programs to teach lessons using modern management stacks. And unfortunately it's being blocked by some graphic. But basically that we can improve tooling and automation with university and or IETF hackathons. I think it's like the idea is that there could be lessons or student projects that could, implement tooling and automation. Next slide, please. And so these will be the insights specific to data. In some network deployments, the focus is solely on service level models, such that device level protocols and device level models are unimportant. This assumes that the existence of a device adaptation layer to transcode service level models, or even more generally, standard models to device level models, or we might call them native models, and to conform to the device specific protocols. 2, there's a need for solutions to not hide vendor specific knobs. Currently, vendors compete by differentiating their offerings in unique ways. The reason why an operator may choose a particular vendor is because of its differentiating features. Will standard models enable conformance, they must not hide the vendor-specific knobs. Yang deviations are a partial solution to not hiding vendor-specific knobs. 3, it was emphasized that streaming telemetry requires picking a model and sticking with it. It is quite a commitment, and the current environment makes the decision harder. The current environment being that there's differentiating ways to doing the streaming telemetry. 4, it was noted that IETF focus should be on defining abstract or service level data models, since it is the only thing that the community may ever agree on, and specifically maybe not worry too much about device level models. 5, there's a point about navigating non-device specific models being difficult. If I understood the comment correctly, the network engineer was saying that they know the CLI command, but they have trouble grepping for it in the Yang models defined by the SDOs. So they just can't figure out how to connect with what they know to what the Yang model is trying to provide. And then 3, and sadly it's wiped out, but I know what it says. It says, and this is when Warren was handing out his magic wand, one operator picked up the wand and said, I have a wish that the IETF and open config data models would merge. Next slide, please. So that's the last slide, actually. I think the next slide just says thank you. So that's it for the presentation. Thank you.
Yeah, thank you. So any comments, clarification? Okay.
Yeah,
I
if there's
have
no
one.
comment,
we move to
I have one. You cannot create a service model without knowing what is a device model. Because if you don't have a subscription, if you don't have a description, what device is able to do, you can create a service model. Fully, like the focus is solely on service level models. And you cannot create a service level model without knowing what your devices are capable of. So this whole approach is, you know, it's a either it was worded wrongly, but if you don't know what is underneath there, how will you develop the service model?
Okay, I think I'll just answer this quickly. In tomorrow's conversation or presentation does it more. But of course, each device has a native model, the native Yang model potentially, and the service model could be mapped to the native model.
Okay, so you're saying that the standard device level, protocols, device level models are not important. Because you were saying here such that device level protocols, device level models are unimportant.
Well, that was the takeaway. I mean, and I think that the gist of it was that the operators are used, and some operators, the larger operators, they have orchestration systems or control. And those systems are by and large only presenting the service level models to the clients, the users, and they honestly don't care what is the underlying device level model or protocol that's being used to interact with the devices.
Okay, Dan. Do you think that answer your question? Actually, I agree with you. You know, this really for service level model, I need to some functionality feature, and for service model more like intent based models. So how the intent can be realized or service can be realized, we can map to the device model to rely on the device model to realize this kind of service. So still, there's some hook, between device model and the service model.
Yeah, Rob, please.
Okay.
At the end of the day,
so maybe we move to.
Sorry, I plus queued. I don't know whether
Yeah, go ahead.
So I think that an operator wants to achieve something. They might not care about the way that thing is achieved, but probably if it can't be achieved, they do care, right? So you have to have some viable way to go and take the service model and map it to something that you can apply to the device. And so like that, a characteristic of defining service models has to be that there is some way to be able to do that, right? And so I think you have to then know, well, what are the ways that you can do it? And, you know, there's been an iteration over the last years of how that's done. We've been building these kind of systems for over a decade, which have used a model to map to vendor CLI and apply via SSH. So they are agnostic, but they're independent, but they have to be relatable to one another. And the focus, I think, on, hey, you should do service models, it depends who you are, right? Like my services at Google don't look like my services at BT. They look very, very different. Like, and so then it's like, well, who are you catering for? What are the standard services that you want to look at? And I think with the experience of the L3 VPN service model, it ended up being fine, but it didn't end up being feature rich because there was so much difference even in the L3 VPN service model between the folks that were working on it.
Okay, I think thanks Robert for clarification. So madam, we move to the next open discussion section.
Yeah, I think we can move to the next
Let me stop sharing.
if you can just share the slides.
Question from Naveen, I think.
Yeah, but for Naveen, I think it's for the open discussion. So we can just have a quick introduction to the slot, and then we can take the questions there.
Should I share or Liz happy to share?
Yeah, please share it, Shane. Yeah, so for the context, yeah, please, Shane, for the next slide, if you can, the next one, please. Yeah, so this is just a reminder. I think. Yeah, thanks. So for just to keep focusing, I would say the discussion and also the question we'll have. This is really to be focused on the new requirements. Those are initially expressed by the operators, but we really want this to be really, I would say, handled in a collaborative manner. That to take into account the inputs and also the feedback from the various people on the call today, but also in the industry, the operator, the networking, I would say the vendors, and also the academia and so on. Next slide, please. We said, for example, when Luis was presenting the local mapping, there's, I would say, and it is really tempting to go to how we can do that. So we really want to restrict ourselves at this stage on going to the distillation related discussion, but mainly to focus on formulating, I would say, the needs and identifying the problems. How this will be implemented, or whether this is, I would say, implementable. This is another discussion that you can have in a later stage. We would also like, I would say, get us ourselves from going, I would say, into very low level requirements that may get us into protocol specifics. I think we just need to, I would say, to have a discussion on the key topics and the key requirements that we really need to solve. The purpose here is not to challenge what the needs from each of us, but to understand it. With the hope and the goal to have something which is really common and achievable by us as a group, for, I would say, so that we can sketch new direction for the network management in the next years to come. Next slide, please. So these are, I would say, example of questions that we would really like to have, I would say, to hear from you. If there are new problems or new requirements that are not, I would say, were not mentioned or described in the various talks we received and also presentations, specific issues on the data models, the protocols, whether we need to obsolete some or quick to have consideration or on the coexistence of some of the protocols, specific requirements or needs for the legacy system, because this is really something which is really important from an operational standpoint. We have seen a bunch of list of requirements. Sometimes this is too much to have. Should we prioritize them? If so, how to do that? Should we receive the, I would say, the prioritization from the operators and then from, I would say, the implementers? We also heard a lot of, I would say, wish list that there needs to work on more, I would say, services, but other than VPNs, which are these new services that we would like to work on, and those that are really worth to have, I would say, standardized models. There are also questions about the collaborations. How do we have, I would say, a specific expectation on this, how to do it? And of course, any question you may have on the scope. So with that, we open the discussion, and I think Naveen is the first on the list.
Hello, everyone. This is my first time joining ITF, so thank you for inviting me. I got to know about this through Mahesh when I met him in AutoCon conference. So thank you for that. So I just wanted to share my experience building a telemetry system. Let me start from scratch. So we decided to use, we're always doing REST API, netconf. We decided to do GNMI. And I want to give a backstory just to understand, like, as an operator, what problems I faced while implementing GNMI and Yang in our system. So initially, we had no idea where to start. I started talking to the vendors, and it was very difficult to find like what is support. If I have all these show commands with me, how do I translate that to Yang initially? And then obviously vendors helped me with open config models. And then we started doing the translation. Open config models are already published, so you can see and work with it, so you know what is supported. But we were not sure about native paths, like where is it documented? How does it look? There was no information about it with vendors. So while I was start trying to find this mapping between show commands and GNMI or OpenConfig, I found out that there were so many things that were missing. Even though OpenConfig has it, vendors are not implementing. I know someone mentioned that as well. So it's like as simple as carrier transitions wasn't present in interfaces OpenConfig model because it's already there. So it took so much time to figure out these issues. Then we had to tell them, hey, you need to add this. And then obviously we have to upgrade our devices so that whenever they add it, we can use it. And then that happened. And then eventually we realized there were a lot of bugs in vendor implementations because apparently no one is using it. So like we have all the major vendors, and they all had bugs, memory leaks. We literally had to reboot a backbone router because I enabled GNMI on it, and it just went crazy. So a lot of issues. We use GNMI sample, and apparently we store everything in time series. So we need a continuous flow of data, right? We cannot do on change for that. So we started seeing all these issues were missed. So we started, if something is not supported in OpenConfig, let's do native paths. Then we got to know native paths don't follow the conventions of OpenConfig. For example, let's say you have /interfaces interface, and then you have the name and as an attribute for the interface name. But one of the vendors had so you always have static keys and a value to it. But in this case, the static key was the interface name. So how can you go through the tree if it's dynamic, like /interfaces /interface /ethernet21? I cannot iterate through that. Now, if all the vendors are going to have these specific things, we as an operator will have to have a system where we're putting hacks for each vendor for their native paths. So we just stuck with open config models. So we just do interfaces and BGP for just one vendor, and for everything else, we had to fall back to REST and netconf, and we continue to do that in our new system. And so I think I'm not sure. So I don't know how we solve things here. I don't have a solution, to be honest. But I feel like there could be more of a process issue here, where if you think about it, in an ideal world, if open config is being used by everyone, if everything is used properly by vendors, everything will maybe be good. So maybe there's a disconnection between IETF and vendors, where IETF is doing a really good job at all the stuff we are trying to propose here, but are vendors doing it properly, or they're just adding stuff just to make it work? And I
Yeah,
have an example for that as well.
yeah, thank you,
Sorry.
Navin. You can share that we said the additional example on the chat, or also on the I would say on the notes. So thank you for sharing this. The next Dean, please. Dean.
Sorry, I was muted. There are plenty of tools available out on the market, and you can decide which ones to use. You can either subscribe to the IETF tools, or you can subscribe to the different types of open source tools. And I really believe there's nothing preventing you to create next generation network management using those existing tools. Are these the best things? That they are not, but you can get the job done. The question is, do you have the right people who will understand and know how to use the tools? You have to figure out, this is the business service that I want to create, and then saying, this is the outcome I want to get from the network. And from there on, you are then deciding to build your network, build a management system. Some people have the job easier in that regard. Some people have it harder, because it depends how much of legacy systems they have in there and how much can be done. I think it is much more interesting to have a conversation how to move away from template-based network management to real programming logic network management, where we are building systems that are that you're creating rules how to handle exceptions, and you create a proper business logic that will enforce that business logic that you want to execute based on the current state of the network. And we still today don't have good exceptions handling systems in the network management. I think this is one of the biggest things that we are missing today in our day-to-day network operations. Which ones are exactly needed? I don't know. I'm not an operator. I would like here for the operators to step in and say, hey, these are the exceptions that we handle mostly on a daily basis, how we could fix them. I've seen there are some documents among the vendors floating where they say, hey, here is a list of exceptions that we have. But having summarized that maybe within the IETF could be a good step forward, saying these are our day-to-day network operations problems. Let's try to see how we can solve them in a different way than what is being done today. I would really like to see us moving away from network config template management into more programming logic systems.
Thanks, Dean. Any other comments or inputs? Yes, Rob, please.
So I think it's interesting that we've had a bunch of sort of discussion about, oh, this is what's hard for operators to implement. But to Naveen's comment, hey, what's the quality of vendor implementations? Why aren't vendor implementations in sufficient quality that operators can consume them? And to Rob's comment in the chat, it's like, hey, it would be great if we had a single way of doing things. Like, what is preventing, what is preventing the vendor software engineers to go implement a single usable stack that's based on the standards that we have today? Do we need more standards, or do we need better implementations? And I heard a lot of from some of the comments, we need better implementations, and that's the big consumption problem, which isn't a standards problem. It's a product management problem. It's a investment problem, and it's a focus problem. I'm pushing for one implementation, and I'm voting with my dollars and my fingers in terms of code.
Naveen?
Yeah, so Rob, I completely agree with that. It's like whatever you guys have done with OpenConfig, it's all great. But if vendor is not willing to do it the right way, it's never gonna work. And I've seen that firsthand. I'm just gonna give one example. I have so many examples, but just one example would be one of the vendors added, in interfaces you have aggregator ID for port channels. Now it's present, but one of the vendors added their own field into the OpenConfig model, which is not there in the repository, by the way. But when you subscribe to it, it shows up. And they just created parent, blah, 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 field for port channel. But it's all, you have aggregate ID. I'm not sure why they did that, but there will be some customer requirement and they wanted to implement right away. And maybe aggregate ID wasn't present at that time. I'm not sure. But vendors are just doing their own stuff just to show that they have, hey, we can do GNMI, and breaking the conventions of OpenConfig. So that's why I feel there's some disconnect. And if I don't know how to solve it, but if there's a way to, I guess force is the wrong word, but a way to make them follow the conventions, then I think we will have a better world there. So.
Rob?
Yeah, so this is sort of reply to Rob Shakir. Why are the vendor implementations not better? I think the obvious answer to that is that it's a hard problem to solve. So particularly when we are trying to map between external models to internal models, as you can imagine, that's a hard problem anyway. But anything where you get differences in terms of structure or complexity in terms of affecting what you support in your hardware or your software stack above that versus what's been modeled, those things end up being really tricky to implement. And even some of it's quite nuanced where like the definition or meaning of a field, the description might be slightly different than what's being done in terms of what's supporting native devices. It also requires engineers who have in general basic knowledge of two things. One, they need to have domain knowledge about like BGP or the specific protocol that they're trying to do the modeling and mapping for, but they also require domain knowledge in terms of either Yang or the Yang language or the model mapping language. And we've moved from a case where we were writing some of this mapping in C code and things towards a declarative language for doing it. That's much better. But again, it takes a lot of time to make that migration. So that's one thing that's really hard. I think the other obvious observation here is that some of these systems are very big and they're quite old. There's a lot of legacy software and you can't change those. And unfortunately, you can't really change the internal data model of the device to OpenConfig or IETF. If we knew the whole world was going to coalesce around one of those and definitely move just on that one, that might be an option. But all the time where there's a question is like, where's the future going to go? Then that's not really an option. And even there was, I think the cost of trying to move our internal data models to a new external one, certainly one that's changing over time, then again, that makes it really hard. So it's like stability as well. So I think it comes down to I think we're trying to do our best, but it's a hard problem to solve.
Next, Dean.
Oh shoot, I lost my train of thought. Sorry, I was listening, thinking about what Rob was saying, and then I lost my train of thought. What I wanted to say.
Yeah,
sorry.
maybe we can swap to Kent, because Kent was wanted to reply to Rob points that you can keep it. Yeah. So Kent, please.
Yeah. So it's all in the chat window. Someone mentioning about compliance tests. I think that's along the line of what needs to happen. What would be good, I think, is if there were some sort of public space where all the different standard models, including both, I'll just leave it standard models, are listed, and then for each of them, some notion of their implementation status, and here I'm thinking a little bit, or tomorrow's discussion about a model adapter or transformation adapters, but is the device's native model adaptable at all? I mean, and I think that was someone else's point earlier, sometimes they don't have the underlying knobs to allow the mapping to occur. Well, that should be flagged. That should be highlighted in this dashboard, if you will, and like score the vendors, and publicly shame them to some extent to whether or not they're implementing the models, faithfully, right? I mean, how they're focused on business dollars, and I don't know how else to bring them to the table, but I know that they look at that kind of things and will drive decisions off of it.
Diego.
Yeah. No, just no. I was looking at or reading what is the conclusions from yesterday, hearing the discussions yesterday and today. I believe that the real problem that we have is a problem of implementation, but not of commercial implementation. The problem that we have is a problem of reference implementations, something that can be used for these assessments on the fulfillment of certain specs or models, etc. Something that is usable as well for making an test of whatever, even the most distant device model to the standard, but that at the end, if it is young, it's going to be young. So the important thing that you can import those data, you can manipulate those data, you can send back some command, etc., for controlling the whole thing and seeing what happens. Not ideal, not necessarily real time, but that allows you to play with this and to play and mix and match the different options as you have, select the most adequate models and make evaluations on whether particular device vendors are following a particular model. I think this is essential. We need some kind of reference implementation. It's something that in the past I have seen that has happened or seemed to happen in the good old days of the starting Unix with the initial protocols. And I'm not going to name one that it's probably, no, I guess that we all are old enough to remember the good old days of Telnet, for example. That was something usable for almost everything. It was not secure. It was not totally okay. It was very much tied to a particular purpose, but at the end it was extremely useful for debugging and working like that. So let me say, that's a claim somewhere in some of the notes, is that having a set of tools, or a tool set, but a tool set that's not fancy, not even optimized, but would allow us to play with all this. And a tool set that is community driven and it has been validated by the community. And I think that this is essential for any kind of validation, interoperability that we need. And this is one of the things that is precluding most the wide adoption of everything that we have been proposing in the last years.
Thank you, Diego. Dean, please.
Yeah, so I think that the network operators are not doing enough investment by themselves, and they expect that the vendors will solve problems for them. So I will say, as an example, you have the open config models, And the open config models are based on what the what one of the, you can call them operators, needed the most, and they said this is what we will implement, and this is what we need. This is a subset of what any vendor is supporting. Now the question is, who will do the transformation from a vendor model to the open config model? In case of the open config main, okay, so of the main participant in the open config, they have enough buying power that many vendors are saying, okay, we will do that implementation for you, and then you can continue changing the services that are based on the open config model according to your needs. But the Google, in this case, they also have enough people who can write their own code and change that. The other operators don't have that. And then there is a pressure to vendors to come in to more and more custom implementations for each operator. And this is something that is not scalable. So I'm still coming to that one, that the tools are there. We don't need another standard. We can have multiple implementations, but as long as we can create the right abstractions, and with those abstractions creating the right interfaces between different implementations that can be iterated, as Rob was mentioning yesterday in his presentation, it's something that could be done independently of whichever release you have on your network equipment. It is more or less like, this is what is supported. Let me see if I can do it. In most of the cases, you can do most of it because each one is using a subset, not a full set of all the features that are available.
Thank you, Dean. Wes?
So comments on two different topics. One is about interoperability testing, because that was mentioned, and then I'll speak briefly about models too. But I'll just remind everybody that the IETF actually went from, proposed draft full standard 3 steps to proposed full, because the draft step was supposed to prove interoperability regardless of whether it was deployed. And to get there, you actually had to write an RFC that was about how you tested the interoperability of this protocol. And, it was like every little feature tested. And 2 problems came out of that. 1, it was a ridiculous amount of work to do that. And then 2, it was only a snapshot in time. And the first time, in the first place, let alone new vendors come along. So it was not that useful, which that doesn't mean that not having a web page with a list of all of the products with it that support different features wouldn't be useful. But worry that it's going to get out of date unless you have like Wikipedia level editorship, right? The other thing I'll note is that converting between models, I think, is the gold standard that we want to get to, but it's sometimes impossible. And I sort of mentioned this yesterday, I think, in chat. Vendors come along and they implement a feature in a particularly unique way to optimize it for something or other. And it may be that it's literally impossible to convert that to some agreed upon standard. The examples that I've seen, I once had to map something onto a Linux IP tables firewall set from a completely different model that really didn't fit that. I think if anybody looks at IP tables that for a system running Docker these days on Linux, the IP tables list is practically impossible to follow because they needed to map. That was the only, mechanism they had to do network isolation. And so the complexity of that gets really, really high, and it may be impossible to actually get a mapping to, some sort of system. So if we assume that there isn't a solution for making an easy map, if not, let alone impossible, where does that leave us? Like, where do we go from there in order to actually achieve, can we do standardization without interoperable mapping? I don't know.
That's a question. So, Richard, please. You are on mute, Richard.
Thank you. Some working groups like IDR require at least 1 reference, if not 2, implementations before a document becomes RFC. I don't know if that was ever considered for network management working groups like NetConf and all that. Thank you.
Torres?
Yeah, so one of these aspects that I heard coming up several times was the complexity and missing tooling in open source, and just a little bit on the feel-good side. I mean, I think there are a lot of problems operators have that are way beyond our pay grade as the IETF, even though we may want to understand them better and see if or what we can do about that. And that is pretty much, you know, they don't know how to deal with open source software. I've seen a lot of, you know, big projects that were based on trying to reduce costs by simply pulling together a lot of open source software and then wondering who the heck is going to support the software and make it work. And that has basically dragged these solutions back and forth. And so I think we have some, you know, open source community within the IETF. They're mostly from the routing side. I've seen them also discussing management to some extent. So maybe that's an interesting follow-up to ask them if we have any guidance or so to help improve on that situation, on how to best apply the open source frameworks and expand them for network management.
Thank you, Torres. Next.
Sorry, who?
Warren.
Okay, didn't know it was me. So I'll just note that requiring implementations makes things often really, really slow, right? If you have a look at IDR, there's a bunch of documents that are basically stuck or, you know, taking a really long time to progress. And one thing we've heard a bunch in here is things like agile development, and the IETF is too slow. If you start requiring multiple implementations or even an implementation, you're likely to end up with that being much, much, much worse. There's also an issue where a bunch of vendors are uncomfortable implementing things until there's a published RFC, because there's a significant risk that the document or protocol or whatever will change between when they are implementing and when it actually gets published. So careful what you wish for.
Yeah.
Ken?
Yeah, I was thinking about Wes's comment, and you know, I think that's exactly it. Sometimes it's not mappable because the devices or the vendors have device-specific knobs, and how do we, you know, bring that together? I mean, we want to have the standard model and it transfers the native model, but then somehow, and of course that wouldn't necessarily take into account the device-specific knob. The device-specific knobs wouldn't be exposed in the standard model, I wouldn't think. But rather maybe they could be augmented in sort of as a side channel. What I'm trying to suggest here is that the standard model is compiling down to the native model, and there's some sort of augment or template or something that has the vendor specific knobs that are also being brought down to the native model. They get merged, and then that's the thing that's actually pushed to the device. Something like this is in my mind. To the last comment about agile development, I think the comment I made yesterday, it was actually a different discussion. It wasn't on this call, but if we had a data model transformation framework, and the transformations could be described or compiled or defined outside of vendor implementation, so you're not dependent on a vendor to update software, then that code could be done in parallel with the development of the specifications, and it wouldn't rely on vendor to do release cycles to keep up with that. So maybe not everything, not the protocol bits, but I think the model parts could go through in an agile fashion.
Thank you, Kent. Martin?
Martin has
Okay.
+1,
Yeah,
not
okay.
a plus Q.
Okay, so yeah, Dean, please.
On the FRR, because there's the open source routing community that is built, that meets regularly at the IETF. They are, I was a contributor to the FRR, and I'm still following what they are doing. What they are really focused on creating an open source routing stack, and they have figured out how to get industry to support them to get the routing stack regularly updated by the group of the volunteers. For the network management, they are not doing except saying, hey, we are getting this management tools, and then we publish our own management models. So you will see they have their own Yang model that they have published. They are using, there was some tries to do the tools to create from Yang models into CLI, but they are not focused on developing any management tools other using the ones that are being given to them or that are available on the market, and developing their own model for the routing protocols that they have developed.
Okay, thanks, Dean, for the last comments, input to the open discussion. So thanks, Matt, to moderate the discussion. And we hit on the top of the end of the session. So thanks everyone to make a great contribution to this, new requirements discussion. And we very excited to, hear, a lot of discussion to talk about the present and also the debate on the protocol and the data model we use today. And so look at the future, we really need to explore how the requirements can be satisfied, how challenges can be tackled. So with that, I conclude the session, and I want to pass the talking to the workshop chair. Any last word?
Yeah, thanks everyone. Let's continue to use the mailing list. We had pretty good discussion there. So between today's session and next, let's continue the conversation on the mailing list. Just a reminder for the notes page as well, if folks have specific requirements that are not captured or even comments on the existing requirement, let's capture them. We will be going through some of that in the last discussion where we are finally concluding what are our key takeaways, what are the primary recommendations, what are our primary requirements that we can try to get some consensus on. So that's our plan for tomorrow. And with that, I'll pass it on to Wes for the last words.
I think you've covered it all. Thanks, Drew. I think the conversation today was good, and I'm really looking forward to tomorrow where we can draw up some conclusions from all of this. So.
Thank you.
Bye, everybody. Thanks for coming.
Take care. Bye.
Bye.
Bye.